Hello from Thailand. First, I would like to thank RT-Thread Foundation to let me have this opportunity to, let's say, share my experience working with RT-Thread in the topic related to code generation. Okay, so let's start my presentation. Okay, the topic for today is about working with digital signal processing, and this is the combination of my experience using RT-Thread, RTduino, and MATLAB Coder. My name is Supachai. I am from Thammasat UC, and yes, I am in academic area. So today we will have a little bit, let's say, touch about the theory here. And at the same time, I also work with the non-profit organization called TESA, or Thai Embedded System Association. And TESA is, let's say, the organization that aims to promote the embedded system technology to Thai engineer. And yes, we, let's say, work as a joint that combine the government sector, academic sector, and industrial sector together. And that is why we have several opportunity to collaborate with RTTech in the past. And thank you for the very great support from RTTech for the Thai engineer as well. Okay, so what is about digital signal processing? Let's say that when we have sensor, okay, such as the motion sensor, that is a kind of the accelerometer, right, to detect the movement, the acceleration here. Yes, we have the signal, but the signal here will be sampling into the software side using the analog to digital converter, or if we use the digital sensor here, the data just come in, and then we have a sequence of the data that represent the original signal. And then the sequence of data here need to do something in order to improve it. And yes, this is the domain of what we call digital signal processing. Okay, so it is about how to work with sequence of number, okay, gained from the physical world. And yes, it is not easy because comparing to algorithm in the domain of the computer software, let's say sorting and including those machine learning here, the digital signal processing here tend to be quite application specific and also depend on the many things here. And then let's say that we have to do a lot of fine tuning on this one, and to fine tune this kind of algorithm, it requires some basic knowledge or understanding of the mathematical concept underlying this DSP procedure here. So let's say that it is not easy, let's say like that. Now, for electrical engineer, okay, yes, I am from electrical engineer background. We have a software here, let's say that is the holy grail in the domain of this one, that is about MATLAB here. The MATLAB is a software that allows us to work with the sequence of the data quite easily, because the basic concept of MATLAB work in the sense of vector and metric and also algebra, and that work quite good with the data that we obtain in the form of the digital signal here. By the way, several engineers do not know that the MATLAB has also some kind of the feature that allow us to move into the physical world as well. That is about what we call the code generation here. So the code generation is the key feature of MATLAB, and the Simulink, that is another tool inside the MATLAB that allow us to do the C or C++ code generation, and then let us use that code for the purpose of the working in the real hardware. And that is why MATLAB is, let's say, one of the major tools used by some, let's say, big industry. I'm talking about automotive, aerospace, or medical domain, because in this domain, we have to work with digital signal a lot, and in order to ensure that the code that we work about this one to be exactly work just like when we do some kind of the simulation inside the MATLAB, then it is a better idea to not write the C or C++ code to replicate, okay, the code that we work inside the MATLAB. Okay, there are several options of the code generation inside the MATLAB depending on the choice of your setting. By the way, today I would like to go into very basic idea of the MATLAB Coder, because this one allows us to make C or C++ code, and that can be combined with our base code that may have another feature such as user interface or something else, and we just concentrate on the processing, okay, just on the processing part only. For working with the MATLAB Coder, this is the basic workflow. So we start by writing the code for our purpose, and then we write some more function so that this function or script can generate the test data and inject to our code so that we can know exactly what look like for the data that we will consume and process. And then we just let the MATLAB Coder application inside the MATLAB do the remaining job to do the code generation. And the output of this one will be the C or C++ code, and it will be inside C and inside C++, so it will be quite portable, and so that we can integrate into our base code and then build into the execute image and run in our hardware. Okay, so today we will show about this one. For demonstration, I would like to use some basic one here, but not easy to implement using the normal programming. Okay, concept that is about fast Fourier transform. Fast Fourier transform is about to convert the digital signal in the time domain into frequency domain. Okay, in the case that you would like to have not just only a single point of time, you need to do it continuously, it becomes the short time Fourier transform, and this one will be really useful in many applications, okay, such as about speed processing. For today, I would like to use a sensor based on the hardware that I have here, that is about accelerometer. I will use just one axis of this accelerometer, and I will show you that what it look like for the time domain and what it look like in the frequency domain. By the way, I will not do the coding in the C directly. I just make use of the MATLAB and then let the MATLAB Coder do the job for the remaining here. Okay, the hardware that I will use here will be the this Infineon based hardware that is about the PSoC6, and that you can buy from the RT website. Okay, and this one will have the additional sensor shield, and this is the combination of multiple hardware, but today I will use just one hardware from here that will be about accelerometer. The software side, for the software side, I would like to use this kind of layer here. So instead of writing the code directly in the RT-Thread, I would like to make use of the user level driver here. The concept is I would like to use the RTduino so that I can reuse the code in the Arduino style with the RT-Thread software environment. Okay, so we have a layer of the RTduino here, so that I will write several code here based on the code that can access to the hardware that is about the sensor here. By the way, the good thing of this one that I will show you in my live demo later is that when you have this kind of user level driver, it will make our life quite easier, and then we can enhance this kind of Arduino code with the API provided by the RT-Thread kernel as well. Okay, so it is the time of the live demo. So I would like to show you first with my original code in MATLAB. So this MATLAB code is to perform fast Fourier transform. So I would like to have the data here coming in. This is the function that I plan to do the code generation into the C code. So I just do the fast Fourier transform here, and then I convert this one into spectrum. In order to do that, please understand that fast Fourier transform, when it processes the data in the form of the sequence of the sampling from the sensor here, it will be output as a complex number, sequence of complex number. It will be the size will be reduced by half because what we have here will be based on the reflect, because the fast Fourier transform, when we perform it, the spectrum will be half of the original data. So I perform this one, and then I convert the complex number into the real number using absolute function inside the MATLAB. And then I can do some kind like this one, such as to find the maximum peak here. And then I just convert this one before returning the location of the peak here back to the MATLAB. To the function that it called. So this is our function that I plan to convert into the C code. And then here, I need to provide additional function here, script here, because this script will allow us to try that everything look good or not. So I just make it a simple, code here to generate the sine waveform that combine two frequencies here, that is about 2 Hz and 5 Hz. And then I call by sending the data into this function here using this one. When you have this kind of the code, let's try to run it first. To run it is quite easy because this is the script that allow me to just run this one. You can see that, this is the original time domain data. It looks quite complicated. By the way, when you use the fast Fourier transform and can convert it into the spectrum, you can see that you will have only 2 peaks, and 2 peaks will correspond to the amplitude of this signal. So my code is ready. So let's go to the next step here. So I just start my MATLAB Coder here. This is an application that allow me to do, let's say, the quick run here for this one. Just a bit. It started here already. So I have to first, choose which function that I would like to do the job for this one. So this is this function here. Just a bit. It quite takes some time. Please wait a bit. I hope that I have only one here. So I just do the selection of the code to do the code generate here. And then just next. The good thing of this one is that it allows us to just concentrate on the flow step by step, and it asks me to provide the test code. So this is the test code. And this one will run our code and detect the format and precision of the data here. You can see that this one report that my code will process the data based on the single precision floating point number. The size of the data will be 100. So just continue on this one. So the next step here is just run to see everything good. In this one, it will do the code generation into the C code and compile and build into the execute one using the internal, okay, compiler associated with the MATLAB. By the way, this code here will be compiled and built for the personal computer, not the hardware that I plan to use for today. That will be about Infineon board. But this one allows us to verify that everything good, because even MATLAB Coder cannot, let's say, build everything inside the MATLAB, but based on my experience, 80 to 90%, more than that should be okay. And this one run. Okay, everything good. Now, this is the final set here. So what we need to do here, we just say that I would like to have the source code here. Output file name will be this one. I want C code. By the way, I have to change this one into something like this one, because we do not have special, okay, hardware for this one. But if you have something like this, it will be better for you. I plan to have the ARM compatible, because this is the Infineon. And this is the ARM Cortex M. Okay, good. Now I need to do some kind of the setting here. This is to avoid the issue. Please understand that the code generation inside the MATLAB mainly aimed toward personal computer. But we would like to run this one inside microcontroller. Yes, we have to deal directly with memory. Okay, so I would like to stop using variable sizing here and try to avoid the dynamic memory here as well. And then generate the code. So after a while, this one will generate code, and the code will be located inside. Okay, just let me find where it is. Okay, so this is my folder here, and this folder, it will be in this code gen here inside lib, and this is the function that I work on here. So you can see that we have quite a lot of files here, but do not panic. What we need is just .h and .c, just .h and .c. Now, how to integrate this one? Yes, first I would like to show you my basic demonstration code here. So this code will be from the example template of this board. Okay. So the lower level here will be the code inside the RT-Thread that runs just the loop for the LED blinking here. By the way, I make 3 Arduino code here. And as I told you, I make use of this kind of the user level device driver. How I get this one? I just get this one from here. I just copy this one and this one into my folder here, somewhere around here. Thank you, RT Studio, because the building of this one, when I copy file to this one, it will do the job for me. And then my code make use of the lower level RT kernel using the message queue. So I just use this one to start the sensor interface, and then make 2 message queue here, and then it will be the loop for reading the acceleration. By the way, I will just use the x-axis only here. I will read every 20 milliseconds for 100 value. That will be about 2 seconds. First, I would like to show you the time domain first. So I just send this one to another Arduino code. This is a good thing. It means that instead of just one Arduino code here, we can have several Arduino code here. This one make use of RTduino feature here to create the second Arduino code, and it will look like just the setup and loop for the original Arduino, just like the same thing here. But this one will do the job by waiting for the data and then do the looping and plot it. Okay, so this is to show you first what it look like here for the time domain. So it's just printing everything here. So every 2 seconds, I would like to show you how I check this one. Please let me make it smaller here. And then this is make this one smaller here. Okay. This is x-axis, the side way. So you can see that. Okay, I have the data here. By the way, this is in the time domain here. Now I would like to have the frequency domain. What I have to do, I have to activate another one here. So this one will do the job by receive the data here, convert this one a little bit into the acceleration value, and then do the fast Fourier transform. By the way, this one, because of the code here, require quite a big memory here. So I have to define the Arduino part of this one with the specific stack size, so that I have to increase the stack size to allow 8 KB here in order to handle enough data for this one. Now, what to do next here is just copy and paste. So what I do here is just I copy everything here in the .h and .c, copy everything here. Now I go to my RT-Thread Studio project. In this workspace, in this one, in this application, I just copy everything, repair everything. The good thing of RT-Thread Studio is that when I add a new source file and the header file here, it will handle everything for me. So what I have to do here is just review everything again. Oh, sorry, I have to change the direction of the data flow. Okay, so instead of sending the data to just display the time domain, I will send this one to the fast Fourier transform Arduino code here, so that it will process the data in the fast Fourier transform code here and then show it. By the way, I need to stop this one a bit, and because the data size will be reduced by half, so I just make it 1 to 50 for the buffer size here. Okay, because I changed something here, I need to do one more time for just one file here. Okay, and then I just download this one to the board. Okay, now let's see. I do not move the board. I need to open this one. So you see that constant value will approve, but by the way, when I check this one, you can see that the checking of this one, let me have the frequency of this one, and if I move it slowly, you can see the peak change. So it means that right now we can detect the amplitude and the frequency of my shaking here. Okay, I try to do it faster, but okay, my hand, I cannot move to the right hand. So, this is the ending of my live demo, and here. This is just the starting point, because when we can perform DSP, it allows us to do much more. Based on my experience, yes, we know that we have quite a lot of machine learning algorithms, but when you talk about sensor, not image, okay, sensor, okay, in many approach, there will be quite limited result on this one. The key result is that we still need to do something with the sensor data, and yes, that is about DSP, so that the feature that we can feed into machine learning will be much more appropriate, and that will gain more result, and that is quite critical for several domains such as manufacturing as well. So that's all for today. So the key takeaway here is that, okay, we can use a code generation for the MATLAB, and then this one will assist us on working on the DSP part. Yes, we need to validate first on the host that everything looking good, and MATLAB help us on this one because it comes with a lot of the functions that allow you to do the validation of your algorithm. And then don't forget that we have to work on the target as well, and the key point is about the memory. So it is not just copy the file generated from the MATLAB and then you can use it directly. You need to do the optimization quite a lot in order to ensure that memory used inside the hardware should not be critical in the critical state here. Such as for me, because my code used just 100 data point, so 8 kilobyte is okay, but 8 kilobyte RAM may be not suitable for many applications. And the last thing is that, I would like to say thank you for the RT-Thread Foundation to have the, let's say, the partner and also about their staff as well to work on the RTduino, because RTduino let my life work quite easier with a lot of the code from the Arduino domain, because this one allow me to work with the user level device driver. And by the way, MATLAB is not cheap. I admit about that one. So check first. And by the way, my recommendation is work with the academic side, because we work with quite cheap subscription. It is a quite cheap subscription for us. Okay, and that will be all of my talk for today, and I hope that you get some idea from my talk. And by the way, if you would like to contact me, you can reach me by using the email. I show you email one more time here. And again, thank you RT-Thread Foundation to let me have this opportunity.